Escape from the Homebrew Computer Club is a modern raycasted 2.5D game for the Apple II. It's going to go over the concept, the technology, and how to play it. Thanks, David.
Thanks. Thanks for all being here. This is a game that I wrote back for the 30th anniversary of the Apple II. And I'm just going to talk about kind of how I came up with the concept and some of the technology behind it. And lastly, I'll show you actually how to get through it if any of you bother want to play it. But for this presentation, you could probably classify the topic as stupid computer tricks. So that's pretty much what it is. But this is really what happened the day Woz showed off the Apple II at the Homebrew Computer Club. The untold story. But going back a little bit in real Apple II history, Castle Wolfenstein was a really interesting game. We, probably all remember the first time we saw it on the Apple II. It was the concept wasn't just running around and shooting everything. It involved the concept of stealth, which is a little unique. It kind of set up a little bit of a new genre. Silas Warner was the author of Castle Wolfenstein, and the bad guys were really, they're good bad guys. But the graphics, I guess it was state of the art for 1979, whenever it actually came out. But they didn't really set the world on fire. I mean, they weren't stunning. They were just cool graphics. They went along with the game. One of the most interesting things was the usage of digitized sound. I mean, Bob Bishop was talking about his technology. We did Apple Talk or an Apple Listener. And Silas Warner used kind of the same concept to use digitized voice for the bad guys. And they would say stuff in German. I don't remember what it was. But when you came around a corner and the German would see you, they'd say, "Hurrah!" That's kind of what it sounded like. Okay. I could never figure out what it was. But it kind of brought some new concepts out. And so when I was thinking about what I wanted to do for the 30th birthday of the Apple II, I kind of went back and I was trying to think of what games really established themselves in the computer industry and how to incorporate aspects of those games. Because quite honestly, I'm not a game developer. I do graphics. That was my career, not game development. So it was kind of a stretch. So I kind of had to look at what was successful on the Apple II in order to just figure out how I wanted to actually go about designing a game as a non-game designer. So Castle Wolfenstein, in my mind, really established a great concept for a game on the Apple II. Apparently I wasn't the only one. The follow-up to that was a game we all know, Castle Wolfenstein 3D, done by John Carmack of id Software. And it really redefined the concept of what a game could be. This is really the first popular first-person shooter. And it established more of the just run around and shoot everything you see concept, which is kind of where we are today still. So the game concept perhaps wasn't as interesting, but the technology was fantastic. And who remembers the first time they saw Castle Wolfenstein 3D and your jaw went, on the ground? So thinking this way to myself, wouldn't that be cool if an 8-bit Apple II could pull off a similar kind of technology concept? Castle Wolfenstein 3D, is a 2.5D raycaster. And what that means is that you have a 2D map, really, and as you do a raycasting from your position into this map, it figures out where intersects walls, objects, and whatnot, And based on just the depth, it draws a scaled scan line, but not a horizontal scan line, a vertical scan line, a column based on the intersection of this ray in 2D space intersecting, a wall. And as you can see, most of the walls, even in this picture, are all pretty much on a grid. There's no crazy, 45-degree angles, and there's no stairs. There's nothing going up and down. It's pretty simplistic, but the effect is still pretty good when you get a really high frame rate. It's very, very immersive, and John Carmack is a wizard programmer. So even on the hardware of 1992, which if you think back then, that was the 486 75s were pretty prevalent back then. This is still pretty low end hardware. VGA running 320 by 200 was the graphics hardware that it ran on. So it really established the next genre that, again, we still kind of have today. So I thought, well, how about implementing a similar technology that would have been absolutely amazing in 1977? And so I made a bunch of just tests trying to figure out, could a 1 megahertz 8-bit 6502 really pull this off? And I fiddled around with it a little bit. I also had to come up with other technologies to make it, as I thought, a good game, and that graphics was only part of it. Input and sound were the other part of it. So I had an idea of doing a routine that would combine reading the X and Y axes of the joystick with sound output, all doing that simultaneously. I don't know if anybody is familiar with programming a joystick, but traditionally what you do, you would read one axis and then you would read the other axis. But there is interaction between that. So if you read one too quickly after the other, you get this this issue where the capacitors don't reset in time, and so you get kind of crosstalk between your X and Y axes. However, you can, with clever programming, read both simultaneously. Now you lose a little bit of precision in your joystick. You don't have a value of, say, 0 to 255. But for a game, just having maybe 4 or 5, positions is usually pretty sufficient in terms of, are you moving slow, are you moving fast, are you moving really fast? And then the idea of integrating a little bit of sound output with it, so that you wouldn't have these long pauses while you make a sound, and then your game kind of comes to a halt. So many of the Apple II games, you'll notice they make kind of like a little stuttering noise as they go along, because they're trying to keep the gameplay going along while generating sound. So I kind of put a little demo together, and I kind of released it to KansasFest Apple II back in January of 2007. And I wanted the full retro experience, so I thought, I'm going to develop this on the Apple II. Well, God bless the people who wrote these games back in the day and these old primitive tools, because I tell you, it's not easy. Nowadays, we are so used to having IDEs and really fast CPUs that when you hit assemble, boom, it's done before your finger comes off the enter key. Well, I pulled it off for the demo, and I'll show you quickly what I released. Now I am running an Apple II C++, so I'm going to restart this in 1 megahertz mode, because otherwise it'd be entirely too fast. And good. Control, Alt, Escape, reset. I really need top.
Don't you have to hold escape after releasing everything
Yeah.
else?
It's open Apple, control, reset with escape key down, right?
Yeah.
Hold the escape key.
And then hold the escape key. There we go. Okay. PC normal? Okay. Nah. So imagine this is just an Apple IIc now. The reason why I actually have a true piece of hardware here as opposed to an emulator, because it actually runs a whole lot better on real hardware. A lot of emulators don't like some of the tricks I do with trying to read joysticks simultaneously while putting sound. So it actually is
Hey,
best.
if it doesn't work right in Sweet 16, let me know, so.
Well, it doesn't work right on an Apple IIgs, period, so.
Oh, okay.
So it does work.
So-
Awesome.
It kind of does, but I like to, you know, cap on the Apple IIgs if I can. So this was just a, the demo that I released, and the concept here is, with real hardware, is the cable's always getting wet.
Nice.
Cool.
This is just a map. Now, I am using low-res graphics. I'll get this in a second. We'll talk about why I'm using low-res graphics. Can anybody tell that's a door?
Yeah. Oh, yeah.
All right.
What happens when you go through it?
I just opened it. Use the for this demo. You just press the lower button, and the door actually magically disappears, so you can go through it. These are windows. Can you tell that's a window?
Yeah. Reflection.
So this is the demo. Now, what's interesting about this demo, believe it or not, this is not page flipping. This is actually rendering each frame starting from the left side per column all the way across. So you can see how fast, even in this demo, you can kind of catch a little bit of the tearing, but it's pretty darn fast. So this was the demo, and you can kind of run through these. It's just running through this map.
Just wanted to know, the windows right now are flat images, not.
They are. They're just flat. You can't actually go through them or anything. They were just they're decoration.
Okay.
So that was our demo. Why did I do the things in that demo like I did? The case for low res. We have a 1 megahertz 8-bit CPU. You know, we're not running high res at 20 frames a second. You just can't push that much memory. So the high res, you know, it gets no love. It really doesn't. I mean, we see Pong on it, you know, from the DOS demo disc, you know, but that's about it. What, Lemonade Stand? I mean, come on. So low res needed some love. That's what I but what it also gives you, not just colors, but it gives you frame rate. And for the game I wanted, it was all about frame rate. It was about a first person, I won't say a shooter, but a first person stealth. So it had to have a really interactive frame rate. Other thing is, because it is full screen, it's more immersive. If you have a fast frame rate, you can forgive a little bit of resolution to get that fast frame rate where you can spin around and move quickly through an environment. So afterwards, somebody was showing me some other kind of a 3D raycast type of games that ran in a little tiny window in high res, which was still pretty impressive, but it didn't give you that immersive feeling. It's like running, you know, Quake in, you know, a little window in the corner of your desktop. It's just not the same thing as going full screen. And so in order to get this really fast, the renderer to get it particularly fast, is I had to unroll the entire rendering loop per column. So unrolling the loop for high res would have been like really, really long. But in low res, you know, you have basically 48 pixel high columns. Unrolling that's not too terrible. And so you can pull that off with 6502 pretty reasonably well. For the sound and input, this was actually as much of a challenge as the graphics. So for sound on the Apple II is fully CPU driven. It toggles the speaker and goes click. You do that fast enough, it makes a tone. The analog input as well requires the CPU to basically set a trigger and then pull on a bit until it goes high, and then you know, okay, that's how long, or how far you have moved your joystick, how long it takes this capacitor basically to charge. So they're very CPU intensive operations, and you can do basically nothing else while they're going on, unless you combine them in a very clever loop that is pulling both axes and toggling the speaker at the same time. It requires a loop that has to make multiple decisions, but has to execute the same frequency regardless of whether a sound is being played or a speaker is not being toggled, or you've already reached the limits on one of your joysticks axes. So the downside of doing all this work in this one loop is you do not get the full resolution of the joystick. I kind of mentioned that. So I think the resolution of the joystick is, I think 32, 0 to 32 on each axis. And your palette of tones is greatly diminished. So you don't get any frequency you'd like. So those are the trade-offs of doing something that way. But the benefits are you have a consistent timed input and sound routine that doesn't arbitrarily affect the speed of the actual rendering loop or the rest of the game. So it's a consistent time allocated for that. And that's kind of important when you're trying to do a fast rendered game. Let's see. Map selections. So of course, a lot of the games of the Apple II era, you know, flat shading was pretty much, if you did any type of maze game, actually they're all just blank walls, they're black. And maybe you saw the outline in white or something like this, and you just kind of chunk, 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 you know, you move, you know, one block at a time. So for the actual textures, I want them to be true textures. So I picked 16 by 16 texture map, an image, for things that would be, you know, the walls, like you know, the door, the window that didn't really look outside, but looked like it looked outside. And 16:16 size texture isn't a whole lot. You're not going to get a lot of detail. You're not going to get text, for instance, written on the wall. You're not going to get, well, you're not going to get much of anything, to be honest with you. But what you are going to get is some hints that will help you differentiate the 3D aspect of our actual level map just enough to make up for the low resolution of the actual screen. Our level map, I created a 32 by 32 level map, and that has something to do with how much memory each level would take, plus when you do the ray casting, how many bits of precision you have to keep as you run what's called a DDA, incremental line algorithm that goes through this 2D map, and you figure out where it intersects. So a couple of like technology-driven decisions left me with these dimensions for the actual level map and the texture maps. And then for the original demo, I didn't have, there was no tools for this kind of stuff, so I typed them in by hand. I got my graph paper out, and figuring out what color everything is, and type in the hex numbers into Merlin. Tedious to say the least. So I figured that wasn't going to be the way going forward. Which finally leaves the Escape from the Homebrew Computer Club 3D, which is what I finally took all the technology, kind of took the concepts of Castle Wolfenstein, some of the rendering technology from Castle Wolfenstein 3D, and came up with a silly premise that includes Woz. It was the 30th birthday of the Apple II, so of course you had to have Woz in there somewhere. And we'll get to the actual premise. But I added a couple things to truly make it a game environment. And that is you have to have sprites. I mean, you can't just have walls and doors and expect to have a game. You have to have sprites. And a sprite is just like a 2D image that is scaled like the Castle Wolfenstein. It's the bad guys. It's the items that you interact, the power-ups. So I needed to have some kind of additional component to the graphics screen. So I added the capability to draw sprites in the screen. I also kind of thought of some other fun kind of things to do. One is animated textures, and this will come up when we actually see the game. But I thought, wouldn't it be fun to have textures that are able to change on a timely basis? So they're animated. You don't know what they'll do. We'll show that a little bit. When you have bad guys, they got to do something. They can't just stand there. So I had to, in the spirit of making a stealthy game, is have bad guys that could, once they saw you, they would start chasing you. So you have to be real careful in the game to avoid bad guys. I didn't want Woz to be carrying a gun. It's just not in the spirit, you know. So,
Segway with spikes in the wheels, but not a gun.
Yeah, exactly. Maybe that next version off the Segway. But Woz is a pretty nice guy. He can't be shooting people. So the game had to be not as violent as, say, Castle Wolfenstein 3D or even Castle Wolfenstein. So he has to be stealthy, and I can imagine Woz being a pretty stealthy guy if he had to. He's big but stealthy, you know. But the bad guys, their AI is, if they have line of sight to you, then they become activated and they start chasing you. Now they're not real fast, but they will not stop until you are dead. It's kind of like a Terminator. But that's actually not true. Once they lose sight of you, then they kind of give up. Or, as we'll see, I had opening doors in the demo. Now they don't just disappear. Doors are actually part of the game. So you can actually close a door, or a door will close on its own after a few seconds. So you can use doors strategically in the game. I also decided that I needed to take advantage of modern tools, and Merlin was just not going to cut it even on an emulator. So I switched to CC65 using their assembler and tool set, which made life infinitely easier. Virtual 2 on the Mac is also fantastic.
Yeah, the debugger is great, isn't it?
Yeah, it would be really hard to do some of this stuff without being able to break in, get machine state, figure out what went off in the weeds. So highly recommended. It's basically embedded programming nowadays. Excellent way to do hardcore development on the Apple II, or even easy, simple development on the Apple II now, I think. Other thing, hand coding maps based on graph paper was no longer going to cut it either. So I wrote a map editor. This is in fact the third level of the game, so you may recognize this later. But I still want that retro feel, so I wrote it in Applesoft Basic. Now I detest Applesoft Basic, and it's an absolute mess in terms of code, but it's also incredibly slow. And so you can't even run it on actual hardware, even accelerated hardware is just impossible. So I run under Virtual 2 on maximum speed setting, and it actually kind of is useful in that regard. But it allows you, this is the top-down view, this is almost kind of like the original Castle Wolfenstein looks. You can set textures for the walls. These little green guys are doors. These little pink squares are bad guys. blue things are power-ups. And you can have individual, there are settings for each of those, so you can go in and tell, say, which bad guy it is, which power-up it is, and which actual texture it is. So this is what I used to actually create the levels. It made life much, much, much easier. The image editor for textures and for sprites. Each level gets 16 textures, images to work with. So this right here would be our evil IBM guy. You can see he's got the blue suit on and the red eyes. So he's definitely evil. In the image, these are the colors that you have to select from the palette. And again, this is a texture number, and there, you can't see it here, but there's like a little cursor you can move around and set the individual colors. One of the grays, although they look different here, they're actually on a real apple too. They look the same. So one of them is actually alpha. So what you see gray around here is actually see-through. It's an alpha of 0. So and when you see this in the game, you only see the blue and the hair and the red eyes and his face. You don't see the whole square around him. Again, this is not the world's fastest AppleSoft BASIC program. You want to run it in an emulator, but thank God we got those now. Made life a whole lot easier. Okay, now let's switch over here. Okay, we've exit out of this. And to go from demo to actually the original version of the game was about, I think, 2 months of development. The later versions, I actually did a ProDocs version so you can install it on your CFFA or hard disk, so you're not stuck with DOS 3.3 as in the original demo. So this would be the opening screen. So this is the 300 baud modem emulation here that you're getting your assignment. So can you guys all see that?
Yeah.
Okay. So it's those evil minions of Tandy, Atari, and Commodore out to get you. Okay, these are the commands that you'll need to get to. It actually does have keyboard commands. There was a request for that, but truly, joystick is the only way to really play it. Button 1 opens the doors. Button 2, you can move side to side, kind of like strafe mode in the mid game, and then you can press them together, and you will flip 180 degrees so you can see what's going on behind you. Wow. Okay. Now, this very first level was kind of paying homage to those original maze games that we would type in from our computer magazines, where you see the outline of the walls all like a grid. See if I can remember where it goes. The other thing I changed is I have 2 screen modes. This is sort of a status display. So down here we actually have our time, and believe it or not, this game keeps fairly accurate timing, all in software. There's no interrupts going on. There's no clock card being pulled, and I figured out roughly what my frame rate was in each mode, and I used that to keep a timer, which is actually fairly accurate, believe it or not. This is the status display. It is rendering less, but you'll see it runs pretty reasonably fast. I can go full screen, and it's just a smidge slower, because there's now more pixels to render. The other change in this over the original demo is this is in fact double buffered. So I'm using both page 1 and 2 of the low res screens to avoid the flicker. That's more because of the sprites that are now rendered on the screen to keep those from flickering. Unfortunately, it meant there was 4 times as much unrolled code to write. So again, this is just what it would look like in those original games. Only now it's a full-on walkthrough. You have, full movement. So that was my little homage to the original Maze games. We'll go through this other side comes through, and now we see that door that's left over from the demo. Now I don't know if you guys can hear that, but my speaker volume is up all the way. This is the sound now. I'm a graphics guy. I am not a sound. I have 0 musical talent, so I wasn't about to go and try to put some music score in there. But sound effects I can do. So now you see we've switched to a room that has actual textures that look almost like something besides just black and white. Now, who can tell me what that looks like? Anybody?
Dr. Pepper?
Dr. Pepper. Sorry, Rich, I'm a Dr. Pepper fan. So these are our power-ups.
Nice.
You know if I tell what that is? M&M's? Yeah. That's the other.
It's a big M&M.
Yeah, very big M&M.
Coffee?
Coffee. And that may be a little harder to figure out. That's a Snickers bar. Once,
That is a Snickers bar.
so now I guess I should mention, now my energy level has gone up now that I've had my power-ups. And once I'm above 85%, if I hit one of these power-ups, it won't take it. It'll just leave it there for later until I run out of energy. But as I move around, my energy starts to drop. So now I'm down to 89%. So throughout the game, you have to kind of watch your energy level. If you do encounter a bad guy and he attacks you, you start losing energy very, very fast. So once you get to 0, game over. So, since I laid out the map, I know exactly where everything is. And let me show you, this is the, how you slide back and forth without turning. So this is the stealth aspect of the game. Is you can kind of peek around a corner, see if anybody's there, get back. For instance, if I open this, what do I find in here? Oh no, he's got me. Okay, so I have to run, up. He's still after me. And when the bad guy has got you, the only way to escape is to basically take your joystick and move it rapidly back and forth. If you're struggling to break free. If you just stand there, he'll just keep beating you up and grab your Apple II and you're done. So, if you make low energy, you'll probably end up closing in. I'll get my Snickers bar. Up there it is. Okay, I'm going to run down this hallway. The field of view isn't super great, so it gets a little claustrophobic. That has to do with some of the technology. When I did the Raycaster, with a lot of, it's all just trig. It's not very, very difficult. But we're all used to, angles in, degrees or radians. Well, I did my degrees in 256. Because that works really great in an 8-bit system. So I have, my whole circle is defined by 256. And my field of view is calculated by 1/128th. So in order to make all this stuff fast, you kind of have to make some compromises. So the field of view probably could be better. And the other thing people might start to notice is, I'll actually see it more, there's a bad guy, but look, there's the arrow to get us out. Well, this is the level 2. One thing you'll notice is a issue called fisheye. And this has to do with the way the raycaster operates. So you're standing in one position, and imagine you're shooting, you know, a line kind of in an arc from where you're looking. Even though we have straight walls, due to the way that these rays are shot kind of in an arc, it intersects the wall in a way that the depth is not linear. So other games won't have this. You can actually apply a correction to this quite easily. I did in fact apply the correction. I have some code that I commented out because I added it very late in the game, so to speak, and the precision of the math that I used was very, very tight. Ended up with some slight errors. So when you come up to a wall, instead of being perfectly straight, every once in a while there'd be one column not quite the right height, so we'd have a 1 pixel problem, and in a low-res graphics screen with 1 pixel, it's really, really noticeable. So I figured with this field of view, with this, you know, resolution, the fisheye wasn't such a bad thing. Kept the frame rates up. But notice in this room here, all we have is one door. But notice that something also different from the previous levels. We have a gray floor and a white ceiling. So we have a little more variation going on now than in the previous level. And the textures try to help it out with the 3D aspect, again, in this low resolution. So in my corners, I put some contrasting colors just to help you figure out where edges are, where lines are.
Is that in the texture, or is that something you're doing at render?
It is in the texture.
Okay.
So creating textures that work at this resolution was a bit of a challenge, so that you could get a feel for what they were supposed to be without either having too much, you get what's called aliasing, where you're only sampling part of the texture and it just turns into a big noisy mess, or, you know, or something that's just entirely too bland. So here is the only door we have in this room. So as we open this door, something happens. Whoa. What's going on here? Well, this is...
It's the Matrix.
It is the Matrix. These are those crazy walls from the Matrix. They have characters, green characters running up and down. Well, low res doesn't afford us characters, it gives us green blocks. And here we can see it's just cycling between two textures. Not very exciting, but at least it's doing something. Kind of confuses the scene. And back here, looks like. Now I confused myself. There we go. Our doors are now green again. Oops, that was where it came from. Let's do this one. Okay. And when you're in the Matrix, what do you have? A blue pill. But I think I mentioned this in my video. I couldn't remember if it was the red pill or the blue pill you were supposed to take, so blue looked better than red in low-res graphics, so blue it is. Those are our power-ups.
So you have different power-ups for every level?
Yeah. And they're basically just a sprite, so they do all exactly the same thing. They're just theme-oriented per level, so to speak.
Cool.
Now, on this level, we don't have guys from Andy or Atari. What do we have? Let's see. Angels. Let's see if we can see if I, oh, see, that's Mr. Smith, right? And he doesn't like us. So luckily I know the way through all this stuff. Oops.
Hey Dave,
Yeah.
can you move forward and look backwards to see the guy chasing you?
Yes.
Yeah.
Run
away, run away.
Oh. I actually opened the door in my face and could get through. So yes, there is a way to turn 180 degrees and see who's, coming at you.
Can you turn it while moving in the other direction?
Yeah, okay, so I'll run through this, put us right back where we were, hopefully very quickly.
Can't you just activate God mode?
Unfortunately not.
IDK.
I wasn't smart enough when I was designing this thing to just give myself a way to get through easily.
IDKFA will give you all the weapons and power-ups.
Alright, so here's our hallway, we'll run down here. So I can look behind me. It's kind of, again, with this field of view that I have. I have a bunch of power-ups here, so I'll get my energy up. What I'll do is I'll leave this in the lobby if anybody wants to come out and play it afterwards. Okay. I know it's kind of confusing when I know where we're going. I'll get to the last level real quick. I'm not sure how much time we have left. Now again, given the limitations of our low-res graphics, this is the telephone,
Nice.
our landline.
Always advertised as abstract art.
So it's abstract low-res art.
Right.
So that's our way out
Nice.
of the matrix. So this is the what I consider the ground floor. We started off in the basement, went through the matrix. This uses a lot of the same textures as the demo. So there's those windows. And the reason why I like these textures is they did a pretty reasonable job of giving the 3D aspect of the walls and giving you some perspective. In this game, I'll give you a hint, don't go in there. That looks enticing. So we go through this door. And this is the library, believe it or not. I don't know if you can tell.
Yeah,
but-
it's awesome. Thought it might be.
That looks like the libraries in Minecraft.
Why read that book? So we'll grab our M&M.
But it's got drill, looks like.
Now we can see if we're. This is just rows and rows. Oh, see, somebody found me. I didn't see him. I'll run away real quick. Look behind me. Okay. There's, see, there he is. There's a door right here that I just know to go through. Another door to go through. And they're chasing me, but our exit sign says Apple II forever.
Hurry. Oh no.
So that was the run through of Escape from the Homebrew Computer Club. I finally made it. So that was pretty much all I had to show you guys today. Are there any questions?
Quick question. Did you do any experiments at all, or think about experimenting with using double low res?
One of the things I always want to do is make sure that whenever I develop works across the board on all the Apple IIs, a double low res would definitely be a step up. It only runs on the 2Es. And my goal is to always make sure that this runs on the very original Apple II all the way up to the kind of the 2GS. Yeah.
Have you sent this to Waz?
Yeah, I sent it to his email account, but I don't think he's all that interested. You know, this is old history.
When you, on the map editor, you did it in BASIC on the Apple II in the emulator. Did you consider generating that on a non-Apple platform? Because, I mean, you could have made a map editor on anything.
Yeah, I could have, and I probably should have. You know, I thought I was going to pound something out real quick. I thought, oh, I'll just do the retro thing and do it in AppleSoft BASIC. Just, you know, because originally I was going to do everything in Merlin, and yeah, I probably should have done that in retrospect. And again, this was, you know, supposed to be for the 30th anniversary. So and going back to Eric's question, I want to make sure it worked across all the machines. However, when I was testing it out on everything from my Rev Zero Apple to the Apple II GS, I noticed something odd happening on the 2GS. I have a ROM 1 2GS, and boy, it just didn't look right at all. Come to find out that I always seem to uncover bugs in the 2GS. The 2GS did not implement page 2 of low-res graphics. When you go in that little control panel, you ever wonder what that alternative display mode was? I didn't know what it was. What it does is it emulates page 2 of low-res graphics by, during an interrupt, copying that memory in page 2 to page 1 so you can see what it is. And that's what, on an Apple IIgs, this will actually flicker quite a bit because it's trying to do this thing in the background of updating the 2 pages of low-res graphics. So that was a little frustrating. Another reason why I have this animosity towards the Apple IIgs. Anything else? I'll put this upstairs and throw it on that big screen maybe if anybody wants to play with it.
How long did it take, like, once you started Escape, how long did it take?
Yeah, the technical investigations, I think I started probably around October of '06, just playing with some of the ideas and concepts. And I don't have an awful lot of time to play with these things, so you kind of have life in the middle. But I kind of got inspired once I saw the demo and was satisfied that the demo was sufficient to go with the game. So the actual game from demo to game went pretty quick. All right? Okay, thank you.